Let us now see the clocked SR latch. The operation of the basic SR latch can be modified by providing an additional input signal. The signal clock or enable determines or controls when the state of the latch can be changed by determining whether S and R or S dash and R dash can affect the circuit. So this is the diagram of the modified SR latch. Two more NAND gates have been added into this. So when the enable input is 0, then outputs of both these NAND gates are 1, and as a result of it there is no change of the state of the flip-flop. So if uh, previous state of the flip-flop is, let us say, set, that is q is 1 and q dash is 0, then in that case uh, the previous state of the flip-flop will remain same, whereas if the previous state is uh, reset, that is q is equal to 0 and q bar is equal to 1, then it will remain in that particular state. Okay, you can say that this is 1, so 1 and 1 is 1, and not will be 0, whereas this, because of this particular 0, so 1 and 0 will be 0 and it will be inverted and it will be 1. Okay, so there will be no change. Whereas if the enable input is 1, then the S and this particular S and R inputs, they determine whether the state of the flip-flop will change or it will not change. In the case if S and R are 0 0, again there is no change. If S is 0 and R is 1, the state of the flip-flop will be reset. When S is 1 and R is 0, the state of the flip-flop will be set state, that is Q will be 1 and Q bar will be 0. Whereas if you give both S and R to be 1, then in that case the the state of the flip-flop is cannot be determined, and this particular input should not be given to this particular flip-flop. Okay. Now let us see the D latch. Okay, that is also called the data latch. One way to eliminate the undesirable condition of the indeterminate state in the SR latch is to ensure that the input S and R are never equal to 1 at the same time. So this is done in the D latch. This D latch has only two inputs, that is data or D input, and enable, that is E input. So you can see here that there is only one input, that is D, and the same input is inverted and is given to this particular uh, NAND gate, and there is another input, that is uh, EN, that is enable input. So the function table of this particular D latch is like this. When enable input is 0, then whatever may be the input, D input, so there is no change. Whereas when the enable input is 1, then if D input is 0, then it will reset the flip-flop, that is Q will be 0 and Q bar will be 1. Whereas if enable input is 1 and if D input is also 1, then in that case it will set the flip-flop, that is Q will be 1 and Q bar will be 0. So this is the function table for the D latch. Now the symbols for the latches. This is the symbol for the SR latch, where S and R here they are active high input, whereas these are the outputs Q and Q bar. This is the symbol for the SR latch with S and R to be active low. Okay, so the flip flop will be set with S is equal to 0 or R is equal to 0 in this case, whereas in this case the flip flop will be set by S is equal to 1, and it will be reset when R is equal to 1, whereas this is the symbol for the D latch. So this is the enable input, this is the D input, and these are the Q and Q bar outputs. So in this particular uh, video, you have learned about the SR latch, the clock SR latch, and the D latch. In the next video, you will learn about the age triggered D flip flop, then JK flip flop, and T flip flop. Thank you.